Okay, so once every year or so, I find myself struggling with a software development problem at my day job that I don't manage to get solved by the time that I head home from work for the weekend on Friday night. But I find that often putting some space and time between myself and the job enables me to have flashes of insight into the problem. And I often see that the problem is not just my problem, but it's a general problem. It's a problem that any Perl developer could have, perhaps even that any developer could have. And I think to myself, if the solution pops in my head, I can make a general solution and I can share it with other people. I can put it up on CPAN. And so I spend a weekend furiously coding to write a new CPAN distribution that meets my needs on the day job and meets perhaps your needs as well. So this evening, I'm going to introduce you to several of these CPAN modules that I've written over the years. All right? I'll describe the original software development problem I was facing, the high-level details of the distribution, and how they solved the problem I was facing. And each of these is a very tightly focused thing. I wrote it in a weekend. That's why I call them a weekend wonder. But none of these modules are groundbreaking. They are, by my own admission, modest modules aimed at solving rather narrowly defined problems in a satisfactory way. Don't get too hung up in the details. I'm not teaching these modules tonight. What I do hope you take away from tonight's presentation is a heightened awareness of where writing some modest but useful modules and sharing them can help you as a developer. Okay, first module is called parsefile metadata. From 2006 to 2012, I worked at a large email service provider headquartered in New York City. The team on which I worked was responsible for receiving data files in custom formats transmitted to us by clients over SFTP and preparing that data for loading into a database via an API. We became very adept at elementary ETL, extract, transform, and load. Usually, we opened up the header file, we opened up the incoming file, read the header row, then iterated over each record to write a munged record to a new file which was sent to the API. But sometimes we received data files that had different formats. One such format had two different sections within the file. A header section that looks like this, consisting of key value pairs which in some sense constituted metadata. And a body section which consisted of data records which were either delimited or fixed width. This particular body section consists of comma delimited strings. Now, whether in the body or the header, comments start with a pound sign and they're ignored. Right? Our instruction was to apply business rules to the header data, to apply business rules to the data from the header to determine whether or not to proceed with the processing of records in the body of the file. If certain criteria were not met after processing the header, we would simply close the file and ignore the body records. Only body records would ever be considered for presentation to the API. Suppose you are told that you should proceed to parse the body if and only if the following conditions are met in the header. There must be a metadata element keyed on D. The value of metadata element D must be a non-negative integer. There must also be a metadata element keyed on F. This file would meet all three criteria, and the program would proceed to parse the three data records. If, however, the F were commented out, the file would not qualify. It would not meet the criteria. What stumped me for a long time was how to read and parse some of the lines in the file in one manner, and then parse the remaining lines of the file in a different manner. And sitting at my desk at work, I couldn't clear my head enough to come up with a solution. It was only when I got home and I relaxed for the weekend that a solution came to me. A solution which, by the end of the weekend, I had put up on CPAN as parsefile metadata. Tonight, I'm only going to give you a high-level, oversimplified description of parsefile metadata. You set up a constructor, which you provide, and you provide the constructor with a path to the file you want to process, a pattern describing how to split a header row on a delimiter, and an array of code references which spell out whether, at the end of the header rows, you should proceed to parse the body rows. Once you have parsed the header, you write another code reference specifying how to process each record in the body of the file. You pass that code reference to the method called process metadata and proceed. To refresh my memory as to how parsefile metadata's development proceeded, I consulted the changes file in the CPAN distribution. I put the first version up on CPAN on a Sunday night. Over the next 2 weeks, I refined it based on my own testing and on feedback from cpantesters.org. Now, it turned out that the thing that I needed this module for at my day job, that project got stalled for 3 months. But in the meantime, I showed this module to one of my coworkers, and he found some errors in the documentation, and I corrected it. So after 3 months, it finally went into production. So at this point, it had been improved both by the result of being put on CPAN and by being reviewed by my colleague. The next module, textcsvhashify. When I started my current job, I was far from fluent in SQL. I worked my way through a MySQL book back in 2004, but from 2006 to 2012, I only had to write SQL about once a year. When I came to immediate math, however, I had to write SQL from the get-go. Toward the end of 2012, I had a big project which entailed a big overhaul of the mapping of advertising audience targets to regional codes. Some regions, such as the new nation of South Sudan, were coming into the regional coding system for the very first time. Within these new top-level regions, there were child regions, such as Central Equatoria and Upper Nile in South Sudan. We also had regions that were getting new code numbers, such as these 5 regions in Australia. And we were creating new regions within some existing top-level regions. Now, as I said, I was just a beginner in SQL, and I could not figure out how to do this data migration. I was just getting lost in subselects and temporary tables and so forth. However, I figured out that if I could solve the problem in Perl first, I would at least have insight into the flow that was needed to subsequently solve the program in SQL. So the data came into us in the form of spreadsheets. Spreadsheets you can save to CSV files. CSV files made me think of the CPAN module called textcsv. And if I get it from a CSV file into Perl, I can put it into a Perl data structure, and I can then manipulate that to my heart's content. I can add new records, reorder the tree, do whatever I need to do. And at the end of it, I can print out that Perl data structure via data dumper or something like that. And I can see, is this the data structure that I need to end up with at the end of this code of this target migration? Not only that, if I print this out and I say, I think this is where we need to end up, I can go and give it to the product manager and she can proofread it. Okay? And if I have that, then I can go back and try to solve the problem in SQL. So that's what I did. TextCSV, it's an old module, but it's kept up to date. It has pure Perl and XS version, so it's fast. But its interface is a bit heavy. And all I needed to do was to say, this CSV file represents a Postgres table. The table's primary key is whatever. And I want to turn this file into a hash. So my solution was a CPAN module called textcsvhashify. This module has an object-oriented interface, but it also has a drop-dead simple functional interface that just says, hashify this file with this primary key and give me back a Perl hash. So, what happened next? I manipulated the hash until I got the desired final state. I printed it out and had the product manager review. Right? She signed off. So I knew what the data had to end up. Then I went back to SQL, and instead of using Perl hashes, I created temporary tables to hold the intermediate state as I added one set of data after another on the way to the final result. And finally, after several months, we put this database into production and effected this migration. The final module that I'm going to talk about tonight is called Git Reduce Tests. So the problem is you have a very large test suite, and it must run on a smoke testing server for you to have the code reviewed or get the code, merge the code into production. But what happens if your smoke server is having problems? What if your smoke server is taking 3 times as long as it was doing last week? Right? That's a problem. And we faced that problem here a couple months ago. And what I figured was, we run this enormous test suite, but for any given branch in the repository that I'm working on, I'm only concerned with a few files. And so maybe what I could do is I could temporarily reduce the size of the test suite and get that through Jenkins, since that was the smoke server that was causing us problems, get that through Jenkins quicker. And so what I figured out was that if I created a branch that was exactly like the branch I was working on, but had a lot fewer tests, and sent that off to the smoke server, I could get results sooner. So, in the case, we do this in the Perl 5 core distribution. To send something to a smoke server, we create a branch that starts with smoke me. Right? Here at Media Math, if we push a branch to the smoke server and we precede it with topic, Jenkins kicks off a smoke test run. So, I wanted to automate the creation of a branch with a smaller number of tests, and I wrote git reduce tests. It's basically a command line utility called reduce tests, to which you give a directory, the branch you're working on, the name of your remote, the test files that you want to include in the small test suite, or alternatively, the files that you wish to exclude, the prefix that kicks off the smoke server, prefix for the branch name, and maybe some verbosity as well. And I would say that since August, I've used this repeatedly on the day job, not just in the case where Jenkins is giving us problems, but also where, for a variety of purposes, I want to be able to run and look at just a few tests at one time. So, 3 modules, they have similarities. They're all weekend wonders. Version 0.01 got to CPAN by Monday morning. But they're modest modules. They have a tight focus, small number of files and functions, and as a result, I get high test coverage. But there are differences among them too. Git reduce tests and textcsvhashify were meant as developers' tools. You could use textcsvhashify in production, but I didn't design it that. I designed it to make my work faster as a developer. Parsefile metadata, on the other hand, was designed to be used in production, and we did put it in production at that previous job. These modules also differ in terms of dependencies. Parsefile metadata is pure Perl. Textcsvhashify wraps around the existing textcsv file, which has some of its dependencies. And Git reduce tests obviously makes no sense if you're not using Git as your version control system. And it wraps around a CPAN module called Git Wrapper by John Anderson, also known as GeneHack, for its current implementation. Now, I did this. You can do this too. The first thing you have to do is recognize when to step away from the keyboard. And of course, when you're doing this, you should ask, is there an open source solution already? If so, you use it. Next, if there's no open source solution, you design the interface. This is what I call writing the documentation first. Then you write the tests and the code, and you get your tools ready. That means having an account on CPAN, which Brian Foy can do for you tonight if he's nice. Right? And you want to share this code, so use a source code repository. The repository of choice these days is github.com. Thank you very much.
Just under 16 minutes.
Oh, very good. Okay. So, any questions?
Isn't that Git module, shouldn't it be under the app : namespace?
There already are several modules under the Git high-level namespace, including, there were at least 3 that I looked at to use as a basis for this. So I think the use of this as a top-level thing is fine.
It's not an app, it's a script you install into Git that becomes a command, right? Like all the other ones.
Yeah, I mean, it's like...
You don't run it separately. Say Git.
No, this is a reduced test is a command line utility, right? But it's just like, say, Xutil's module maker. There is a CPAN distribution in this customary format, and one of the things in that CPAN distribution in the scripts directory is a utility called module maker. And when you install it, the library gets installed to, say, user local lib, and the utility gets installed to user local bin. Same way here, you install this, most of the library goes into a lib directory, and the utility itself goes into some sort of
Does the
bin
library
directory.
have a public API, or it's strictly for the internal use of the /bin part?
Well, it's all documented on CPAN, so you can check that out
the
for
other
yourself.
question is, because you're reducing the number of tests, wouldn't that make the merge then invalid?
But you're not merging this branch. This is a throwaway branch, right? You're sending and it's useful in situations where you need results back before you push the branch that is going to be code reviewed and approved for merging. It's for the developers.
It's not the ultimate branch that will get
No,
merged.
no.
Okay, because for a second I was like, that sounds a little bit weird if you're reducing tests before merging to the main,
No.
and now that sounds like you're breaking the rules.
It's a developer's tool. Right? Any other questions? Yes.
Who gave textcsvhashify a 1-star review?
That one can't spell beats.
You know, it was someone who actually looked at the module in the original review process and sent me a patch to correct something. And his complaint was that the module wasn't fast. Well, as I stated here to you here tonight, this was intended to be a developer's tool, right? I didn't use this in production. I used it. It wasn't to make production go faster. It was to make the developer go faster. So it's basically going to be as fast as textcsv, and if you use the XS implementation, then it's going to be fast enough. But it's,
Very familiar with that.
it's
1-star review.
yeah. I know. I was disappointed in that. But, Marty?
I like the way you broke up the problem into 2 parts. One was like coordinating with the business manager first to make sure that the specs were perfect before you went and did the project. That was a good tactic.
Yeah, I was very glad that I did that, and this module really saved my ass there, because I got the Perl solution in like 3 hours time. The SQL, that was like 3 weeks time.
Were you able to use your Perl source and design the SQL, or just in terms of the data structure? I mean, I know was the actual Perl code useful in the SQL, or is it just merely the data structure?
Basically, the hashes I needed to create in the process to get to the final solution suggested which temporary tables to create in terms of the database branch. Okay, I turn it back to Charlie.